To see how microgrid technology is integrating clean energy to offset diesel power, I've come to one of Canada's leading research centers. Hi.
Oh, hi. How are you? My name is Canizares. I'm a professor from the University of Waterloo, Faculty of Engineering. I'm part of the Electrical and Computer Engineering Department. And we're working on, part of our work involves microgrids.
So essentially what your research is looking at is trying to figure out how to get communities that are in the far north off of diesel, utilizing renewable energy.
We have done with Hydro One. We have done it also with the WWF.
What is the main source of renewable energy that is connected to a hydro grid?
Well, it depends on where you live. Yeah, in Ontario, for example, the resources as such that solar is an option. Okay. When you go into Nunavut, you have a lot of wind, so then that's a good option.
As a researcher, what has been your biggest challenge in terms of working on microgrids?
Most of the challenge has been the control, how you coordinate all of this, how you make all of this work together. Communicate, interact, basically supply the load.
So where are we going next? We're going to go see actually a microgrid.
Part of this work has been with Canadian Solar. Canadian Solar invested a lot of money into developing a microgrid test facility.
Oh, great. Should we go check it out then?
Certainly.
Okay, let's go. Thank you. Hi.
Hi, Melina, Mike Carter. Nice to meet you.
Nice to meet you too.
Oh, yeah, nice to see you again. Welcome to Canadian Solar.
Thank you.
And this is our operations and maintenance headquarters globally, and we're excited to show you how they're made. Follow me.
Okay, great. So you have projects all over the world.
We do, yeah. So we're supporting projects in over 100 countries.
Wow.
We have offices in 20 countries and manufacturing facilities throughout South Asia and South America.
I didn't realize that Canadian Solar was so big. What do you want to show me first?
Let's go check out the line, yeah.
Yes. This where the glass is, this is the glass of the actual panel?
Exactly. When we do the manufacturing process, I like to think of it as a sandwich. So what we're doing is it's about a 5-layered sandwich. This is going to start as the bottom piece, but when it actually goes into the field, that's the top piece. Oh. So right now we're going to build this sandwich upside down, starting with the glass. Yes. Yeah. This is the melted cheese. We're going to put 2 slices on around the cells as we get there.
Oh, okay. It's pretty amazing to see how solar panels are actually manufactured. Just like how the electrons are going to be just basically transferred through the wiring to make them actually produce energy.
It really is interesting. Anything from a 10 kilowatt project all the way up to a 100 megawatt project. At the end of the day, it's just a series of individual cells connected together, just as we see here. Why don't we go and check out the Microgrid Test Center and show how some of these are actually put into practice.
Awesome.
And we're going to head in to see our Microgrid manager, Peter Thu.
Hi.
Hi.
Melina.
Welcome.
Nice to meet you.
Carry on.
Hey, Peter. Good to see you.
Welcome.
Peter is the manager of our Microgrid Test Center. He's going to tell us a little bit about what the Canrail facility does here and how we support northern remotes.
So this is what the system is right now online?
Yes.
Okay.
That's basically the single line of the system, right? So basically here we can see we have all the components. Let's say we have the traditional diesel generator, we have PV arrays, we have wind turbine, and we have simulators, because we know each of the remote communities, they would have different profiles for resources. So here, we have all of this, considered, and we can simulate their resources and their demand.
Microgrid concept really came from the idea of a diesel system supporting a completely isolated, unconnected community. What we're talking about nowadays is renewable supported or high renewable penetration microgrids, the idea of offsetting diesel.
So what room is this?
This one is switchgear room.
Switchgear room?
Right.
Okay.
To control all the switches, all the components, just basically open or close the switches, either connect to the component or disconnect the component. Okay, yes. Please come this way. And this is the brain of the whole microgrid.
So this helps communicate between all the different parts of the system?
Yes.
And the operational goal is to integrate as much renewable as we possibly can without creating an instability in the grid, and that's really the brain's job to resolve.
This is the diesel generator?
Yes, that's a diesel generator.
The history of the Canrail facility is specifically surrounding off-diesel remotes. That was the original intent, the original purpose, and so obviously a diesel generator is central to sort of the starting point of the entire facility. And then obviously us incorporating our solar, we recognize that wind plays a big part in northern remotes.
Where the batteries?
Exactly.
This is the key component to fill the gap. whenever we have either wind or solar intermittency.
Then it relies back onto the battery.
But then what happens when the grid doesn't behave exactly as we normally expect it to behave? What happens in a storm event? What happens in all those types? We can actually simulate that here with real power at the test center and determine that, okay, the battery's going to work, the PV's going to stand up, the wind's going to be okay, and nothing's going to happen with the power quality. That's what the test center's here for.
So before a community actually implements, the testing has been done. And when you go towards implementation, they know that there's a validated way and mechanism for doing so.
Yes, to mitigate the risk before even starting to build.
I think that's the exciting thing about microgrids is communities being able to own their own power, be in control of their own power. And I think that's really exciting. So thank you for showing me today. And it's really good to see a research center and the people that are helping run it and keep it going. Thank you so much.